and I'm going to talk a bit about business-driven data integration automation, which in the end saves you time and costs and makes you deliver better results. My name is BANNWART. I'm product manager for Datavault Builder, the automation solution I will give you some insights within the next 20 to 30 minutes on. And the topic we're going to talk about is how we can combine various data sources into one cleansed data set and provide that data then for further data analytics on top of it. Now, the environment we're working in is basically the setup that we get more and more data. There is vast different types of data sources emerging, and once we have set up certain data pipelines and certain sources connected and integrated with one another, we're quite certain that there will be a new source of data coming in very, very soon. And this means that this integration process is not just a one-time task, but it's a task which needs to be done over and over again, and you need to be able to manage the maintainability of bringing in as well new data sources and understanding the data sources in order to be able to connect these sources with one another. How do we do this currently? How do we typically approach such a data warehousing project where we integrate data? Well, it involves many different tasks. It involves creating data models. It involves then from these data models generating code which actually integrates our models into the infrastructure, into databases to hold the data. It involves creating processes, ELT processes or ETL processes to actually extract the data from the sources and move this data from A to B. And once we have to set that all up, we also need some kind of orchestration agent which automates the task, so which on a regular basis triggers that we automatically get new data, that we refresh that data, that we compare it against what we already have, and that we can update our data marts with fresh data. Overall, data warehousing is software developing. That means we also need to be able to version what we are developing. We need to be able to basically branch code versions of new features which we are developing, and need to be able to test this over time. That means we need to be able to deploy code changes in a tested manner, which adds another degree of complexity to this data warehousing integration tasks. And once we have set it all up, we also need to document what we have done. Meaning, not only we need to document what kind of data marts are there, but how the core warehouse layers look like and how the data flows from the different sources all the way to our data marts to understand what kind of data we actually are looking at. And this can, in the end, mean that we have a very, very complex process, because this includes different tool sets or tools which are necessary to fulfill the different steps in this data integration process. Now with Datavault Builder, we actually integrate the different functionalities which are necessary to develop a data pipeline, to develop data model, to run and orchestrate the loads into one automated and standardized solution. Why standardized? Because you can automate what you standardize, and standardization also helps you to, in the end, improve the overall quality. Because when you are relying on standardized patterns, that means that what you are actually implementing is pre-tested. You don't have to test these patterns yourself, which means it also lowers your maintenance efforts and the risk, so you can really focus onto the task of creating models, and you don't have to take care of how these models will actually be transformed into the working code. But we'll get to this, what I mean with translating a model into working code. So Datavault Builder the heart of Datavault Builder, it's a core business concept. So we usually start out with a business model to understand what kind of business entities do we have. So here in this sample, we actually have a model around flight data. So we have in the middle the blue boxes, which are in the Datavault modeling approach, the hubs holding the keys, and then we have the relations which state how these entities relate to one another. We don't, in this state, connect it yet to any kind of source delivering the data, but we just start with a business model, with a core business concept around a business process to understand what entities we're talking about. And even with this sample with flights, it can be a different understanding from the business side than from the IT side what is meant by a flight, and thereby also the implementation afterwards can become quite different. So for a flight, in my understanding, a flight is going from airport A to airport B at a certain point in time. Okay, now I was working at a ground handler. For some of the data analysts, that was also their understanding. And they were building KPIs on top of this. But a flight for some of the analysts there was not going from A to B, but it was the pushback between two flights in my view. So that meant basically if you have different understanding of what that object is, certain data analyst was providing completely different set of data to deliver KPIs on top of it. And that's basically where we really start here, to get a common understanding and document this before we then, in the next step, turn this into, connect this with data coming from the source, because only if we understand what kind of objects we have, we can actually connect the dots and bring in the data from the various data sources. So starting with this data model, we can collaboratively work on this core business concept to gather this common understanding, giving meaning to the context of data. And this is a way of central communication between the IT and the business prior to then actually going and implementing it. With Datavault Builder, we then take this further. So we don't just stop there and build this core business concept, but we take this business concept and we turn it then into an actual implementation which can process the data on your target platform. Meaning, whatever you see in the visual interface, it gets translated into table structures, ETL and ELT statements on the database in real time, and we can in real time then also test our assumptions while we are talking to the business side. So, meaning, if we go here further into detail, that doesn't work. So here the mid part is actually the heart of the warehouse. So that's where we start out with defining this core business concept. And then in the next step, because we have an integrated solution, we can go back and we have a staging module which actually allows us to bring in now the data from the various sources and map this data into our core business concept which we already have developed and actually feed it with data. And we do this in real time, meaning while I'm sitting there as well again with my business users giving me feedback about the understanding of the data, I can directly test and validate whether what kind of input I retrieve is actually working or not. So for instance, identifying keys. So what is the key then for this flight we just talked about? So it might be the flight number, it might be the flight date. In the sample of flights we also have a specialty about code-shared flights, so it might be the same flight but which is code-shared between multiple airlines. So we also need to include that additionally to make a key unique. And then we can directly test, is this working or not? And actually in that sample I can tell you it's not, because there is a specialty to flights, which is they're so-called bus stop flights, which basically start at a certain location and they go to point B to point C. It's still the same flight number, same flight date, same carrier, but it's a different part of the route. So that means to also need to include a further property. May this be the origin airport, may this be the time of departure into the key to actually make it unique. But we can make this really iterative and quickly and directly validate if it's working or not, because we can take that core business concept which we initially developed and directly connect it to the data now and test the results immediately. Now once we got into the core layer, that's where we historize and persist and integrate the data. We afterwards also need to make sure that we make this data accessible. And that's where the business objects, or in other terms, denormalization layer comes into play. So we create, on top of this core warehouse layer, we can then create interfaces delivering this data to data marts in the different formats needed for the corresponding reporting platform. So meaning if you're having a classical reporting tool, we'd probably create more of a star schema or dimensional model, or if you are having other tools which were working better on really flat wide outputs, we can also denormalize and just put it into flat wide tables. And then directly again make this accessible and testable, so we can really quickly deliver reports, and while we're doing this, validate again our assumptions from the business side. But that's just one part to it. The second part is also supporting the software development cycle. So creating the models, creating the data flows, it's just the one part. Once you have done that, you actually need to bring these changes from your development environments in a tested manner onto your productive system. So you need to cover testing, you need to be able to do comparisons between what the current state is of your productive instance. And that's where we also have an integrated solution to actually do a comparison between the different states on a logical level and create deployment packages. And then test these deployment packages in an automated manner and ship these then to a productive instance. While at the same time, while we are building the model and generating the code, we're also building up the operations part around it. So meaning we're building jobs which directly pick up the loads, and so we can automate the refresh of the data immediately while we are actually modeling. So we don't have to go into separate tools to do this, but we can do this all within one integrated solution. Now, what do we really do different? And I've just touched this. Besides integrating multiple aspects necessary to build these pipelines and run these pipelines, one key difference is the way that we interact with the database, so with the implementation side. So in a classical automation approach, a modeling tool is holding the metadata about your data model. So when you're creating a data model, all the information, how the objects relate to one another, is stored in a metadata repository. And once you're finished and you have your nice model created, which works in theory, then you push a button and you generate the structures, and then you can start test the loads. And then you have the actual implementation, which gives you feedback if it's working or not. Now with our solution, we actually directly connect onto your database. So you have a sandbox or a dev environment, we directly connect onto your database, and in real time, what you are implementing in the modeling interface, it's translated into working code, so that we have a really shortened feedback cycle. So it means what is displayed in the interface is actually what is implemented on the database, which on one term means we can immediately test, as I stated before, but on the other side also means that we don't run out of sync. So I'm quite certain you had this in the past when building data models, nice data models, you deployed them, and after some times there were some tactical solutions, I would call it, some direct changes, and it would run out of sync, and then you're never able to basically get this into sync again because you manually have to bring it back into your developed data model. And this cannot happen here because it directly syncs and displays what it is there. So, meaning if we're looking at the data model represented again on the left-hand side, this is translated in all the metadata as comments or directly stored on the technical object on the database. So for feedback cycles, that really means that in a classical approach, you have the steps from designing over then generating the code to deploying it to your environment. Then you can start processing data, and then you can start testing, and then you probably iterate through this cycle a couple of times because you notice certain improvements which need to be done. With our approach, because the steps are all done simultaneously in real time on your dev environment, you can immediately test it. So you don't have these steps serially behind one another, but directly within one another. Of course, in the end, as I said, you need to deploy the changes from one environment to another one, but on your environment, new features you can immediately test and thereby really closely collaborate as well with the business side. And that really saves time because it makes communication easier, and thanks to the standardization, it makes the implementation easier because the implementation in the end is derived from this core business concept which we create in close collaboration with the business side. And it's based on standards because the automation part, whenever you want to automate, it only works if you are basing it on standards. And standards have, in our case, are strict Datavault modeling, so that's what also the tool is called Datavault Builder. So we're relying on the Datavault methodology. We are applying strict technical naming conventions, which look the same for all clients. Of course, the model looks different, but the technical implementation, the way it is derived from your model, it's for all of them the same. So that means that we can improve the patterns as well. So we have, for that, we have partnerships with the database vendors as well, onto which we actually then generate the code for the implementation to make sure that the patterns we are generating are also fine and are benefiting of the individual features of the respective database. And we're also bringing in feedback in the community or from the Datavault Builder experts, Datavault community experts, into the continuous improvement as well of the application. And that means that over time, we can, based on the model which stays the same, we can update as well the technical implementation. So just to give you a sample of that, for one of our partners, which I had on here before for Exasol, they actually introduced with one of their database versions, they introduced a new data type. And we actually supplied change patterns, an update script for the already loaded data. And by providing this, by upgrading the database and upgrading the solution with the improved patterns, the speed up for existing clients was up to 300% for the loading times. And that's only what you can do if you separate basically your model from the conversion, from the technical implementation in the end. So how does it work behind the scenes? In simplified terms, the application sits on top of your database and orchestrates all the creation of the objects. It orchestrates the loading statements to process and move the data. and it delivers then as well the data on the database for further access by data consumers. In more detail, and that's just for the ones familiar with Docker, it's a set of Docker containers which in the end talks to your database. So whatever you do in the front end, it directly is connected to your database. It directly integrates the changes. It fetches the metadata of your database and represents the current state derived from the database. So that means in sum, you can basically deploy it anywhere where you like. You can deploy it in the cloud, you can deploy it on-prem, or you can also have it run as a SaaS version. Just to name a couple of clients, there is not like a certain typical client. I would say it's whenever you have multiple sources of data, that's where Datavault, of course, makes sense. If you just have one source of data, I would say this is an overkill. But if you have multiple sources of data which you need to integrate into one common business concept model, that's where it can make sense. And just to name a few companies, on one hand side we have, for instance, here a company called Totally, which is a UK and Ireland based healthcare provider. And what they do is they're highly relying on reports which they are providing, KPIs they are providing to governmental bodies, so they need to make sure that the data they are actually reporting on is correct. And their setup was that they had multiple data warehouse modernization attempts, which they did, but the users trended to shift back to the old solution because basically they trusted the output which was coming out of the old solution more. And over time they just had a slowing down development speed for these new approaches. And with a standardized solution from Datavault Builder, they were actually possible to really deliver now the data warehouse modernization and a new data warehouse, and also gain the trust of the business users actually consuming the data, because they could rely on the standardized patterns, they could rely on the standardized process then, which allows you, as I said, to come from a business concept, connect it to data. It's always the same process, and it's like being on rails to process the data, to create the data models, to also then deploy these changes, which also allows them to really efficiently onboard new team members, as it's always the same workflow. On the other hand, we have ProSiebenSat.1 Media SE. For the ones which are not familiar with ProSiebenSat.1, that's a leading entertainment brand in the German-speaking region. They're operating different TV channels and online channels. And just to name the dimension of the team size, they're having over 40 developers. And there it's really a challenge to basically enforce standards in development, because you need to keep in sync when you set up a data warehouse project in that scale, that you have standards how the parts which a certain developer is creating can also be integrated with parts another developer is creating, and is enforcing certain standards so that in the end the output can be combined and also maintained over time. So it's not only depending on a single developer. So that's just two extracts of customer samples. We have also been part of the data management survey performed by BARC. We got compared to different data warehouse automation solutions. We got top ranked in different categories. What we are especially proud of is the part about time to market, meaning that this approach which we're following, from really involving the business into creating the core business concepts and directly creating the implementation, and thereby accelerating these feedback cycles, really is also what the clients in the end see on their projects turning it into a success. So instead of having multiple different tools which create interfaces which need to be maintained over time, with Datavault Builder it's really one solution which puts you on rails to cover the functionalities necessary to develop and run your data warehouse. With that said, it was a pleasure having you here. Thanks for your time. If you're having questions, we're also just outside the speaking area at booth 855. Feel free to also visit our website on datavault-builder.com or reach out to us via email. Thank you very much.